Okay, so let's do this problem. It's telling us an experimental setup designed to measure the resistance of an unknown resistor R using two known resistors R1 and R2, the variable resistor R3, and a voltage source and a voltmeter is shown. Okay, so we have this formation here. So which relationship gives a value of R when R3 is adjusted so that the voltmeter reading is 0? Okay, so this circuit is called a Wheatstone bridge problem, and we use it to measure resistances that we don't know. Okay, so when the voltmeter is going to be 0, then that means that the voltage drops across R1, that the voltage that drops across R1 and R2 is the same as the voltage that drops across R and R3. Okay, so another way that we can draw this is like this. Okay, so it goes like this. Right. Then like that. Okay, so now we'll draw it like this. So this is R1, this is R, this is R2, and R3 right here. Okay, and so this voltage drop, that's going to be the same. This is going to happen when the bridge is balanced and the potential that's at the two midpoints is equal. Okay, so from our diagram, the way that we can set this up is that this is the top, let's say, okay? Move this to the middle, right? So, but this would be the top, this would be the bottom. So when the voltmeter reads 0, then that means that the potential that's at both of the junctions is the same. Okay, so that only happens when the voltage drop across R1 is equal to the voltage drop across R2. And the voltage drop across R is equal to the voltage drop across R3. So the way that we would set this up is like this. R1 over R2 is equal to R over R3. So this would be the balance condition of a Wheatstone bridge. Now you might ask that why is it not these two on the same side, right? Why is it not R1 over R is equal to R2 over R3? The reason for that is that our goal is to compare resistors in the same branch, not across branches. And this wouldn't tell us anything about the voltage balance. R3 over R2 or R2 over R3 is the same thing. They're both part of the same branch segment. And this wouldn't tell us, about the voltage balance. So the way that we would actually set this up is by doing resistance in the upper left over resistance in the upper right is equal to resistance in the lower left over the resistance in the lower right. So upper left would be this. So it'd be upper left, R1 over R2 is equal to resistance in the lower left, R over R3. So now our goal is to get R on itself alone. Okay. So how would we do that? You would multiply by R3 on both sides. That would cancel out both of the R's. So then you're left with R3 times R1 over R2 is equal to R. So that's our answer.